Here is the next example. Here also we're finding the Z parameters. So as usual, the first thing, always take every current is entering into the circuit, I1 and I2, V1 and V2. Okay, so since we're finding the Z parameters, Z11 equal to V1 over I1 when I2 equal to 0, and same way I'm going to find Z21 V2 over I1 when I2 equal to 0. So here I'm going to find these two parameters first. Here I'm taking I2 equal to 0, so the voltage drop across this 5 ohms is 0 volt. So I can take this voltage as V2. Now to get Z11, I'm going to take loop 1, apply KVL, loop 1, apply KVL. So to do this problem, you have to have knowledge about the dot convention and mutual inductance. So mutual inductance is nothing but because of the current flowing in one coil, there is an induced EMF across the other coil. So because of current flowing in J8, there will be induced EMF here. So in this case, I don't have any current passing through J8, so E1 equal to 0. So before going to the loop equation, let me write it down. E1 equal to basically J4 times I2. Okay, is it positive or negative? That depends upon the dot convention. So as current is entering the dotted terminal must be plus. So that's what my E1 equal to. Okay, now I know this value is 0 because I2 equal to 0. So this value must be 0 because I2 equal to 0. Now if I write the loop equation, it's going to be V1 equal to minus J2 I1 plus J6 I1 plus E1. Okay, so you have to include the E1 plus 10 I1. Okay, so I know that E1 equal to 0, so I can eliminate that. So V1 equal to 10 plus J4 I1. So V1 over I1, which is Z11 equal to 10 plus J4 ohm. So that's my Z11. Now we're going to find Z21. I'm sorry, it's not Z22, it says Z21. Okay, so Z21 is nothing but V2 over I1. So here is my V2. V2 is the voltage drop across this J8 and 10 ohm. Now because of the current flowing in the first coil, there is an induced EMF across the second coil. What is the current flowing here? So let me label that voltage as E2. Okay, E2 equal to, in this case, E2 equal to J4 mutual inductance times I1, because current passing through this is I1, current passing through the first coil, which is J6 ohm. Okay, E2 equal to J4 times I1. Now according to the dot convention, current is entering the dot, so the dot terminal must be plus and minus. So dotted terminal must be plus here. Okay, so can I say my V2 in this case, V2 equal to E2 plus 10 I1. So E2 is nothing but J4 I1 plus 10 I1. So my V2 in this case, or V2 over I1, which is Z21 equal to 10 plus J4 ohm. 10 plus J4 ohm. Okay, so as I mentioned in the previous videos, it's always easy to find Z11 and Z21 together. Now I'm going to find the remaining two parameters. So the remaining two parameters, I have to find Z22 equal to V2 over I2 when I1 equal to 0. Same way, Z12 equal to V1 over I2 when I1 equal to 0. So since I1 equal to 0, I can ignore this capacitive reactance in this circuit, because there is no voltage drop across the capacitor reactance because I1 equal to 0. So I'm going to redraw the circuit. but I will include the capacitor reactance too to avoid any confusion. So 2 minus J2, J6, J8. So that's J6, that's J8. We have dots here, and this is J4. Okay, now here is my V1, here is my V2, and I2 is not 0, but I1 equal to 0 in this case. Okay, now this is my V2. Okay, is there any voltage generated across this J8 ohm because of mutual inductance? No, because the current passing through this is 0. So whatever the voltage here, say, let me label that as E2. So current is entering, so E2 equal to 0 in this case. So here E2 equal to 0 volt. So now loop 2, apply KVL. So if I apply KVL, V2 equal to 5I2 plus J8I2 plus this is 10 ohm, 10I2. Okay, plus E2, but we already know E2 equal to 0. Okay, because E2 is nothing but J4 times I1 equal to 0, so this value is 0 volt. Okay, so V2 over I2 equal to Z22, which is 15 plus J8 ohm. That's the third parameter. Now it's easy for us to find Z12. So my goal is finding V1. So since there is no voltage drop here, V1 is right here, the voltage across these two. Okay, so V1 equal to, I know the current here is I2. Now I1 is 0, but at the same time, because of the current flowing in the second coil, there is an induced EMF here. Let me take that as E1. What is E1? E1 equal to J4 times I2. Okay, and which one is positive, which one is negative? Current is entering the dot, so the dot terminal is positive, so the top one is positive, bottom one is negative. Okay, so V1 equal to E1 plus 10 I2. E1 is nothing but J4 plus 10 I2. So V1 over I2 equal to Z12. I have 10 plus J4 ohm. Now I'm going to write down everything together. I have the Z parameters, which are Z equal to 1 1, and I'm writing them in matrix format. Okay, equal to 10 plus J4, 10 plus J4, 10 plus J4, 15 plus J8. Okay, now these two are same quantities, so Z12 and Z21 are the same quantities, so it is reciprocal network. So if it is reciprocal network, we can represent this by using Z model, by using T model, my apology. So if I draw the T model, here is my T model. Even my system is running slow. Okay, here is my V1, I1, I2, V2. So this is Z11 minus Z12, Z12, Z22 minus Z12. So I have 10 plus J4 minus 10 minus, or 10 plus J4. So basically what happened here, this quantity becomes 0, and here it is going to be 10 plus J4, and here 15 plus J8 minus 10 minus J4. So when I draw the T equivalent circuit, this quantity is 0. All I have here 10 plus J4, and here 5 plus J4. This is the T equivalent circuit. Thank you.